Hi guys, Ms. Raymond here. Today we're going to talk about LOL graphs. To do so, we're going to need to use Unit 3 Worksheet 1. So take that out now. Okay, so this is Unit 3 Worksheet 1, and we're going to start with question number 1. On the top of your worksheet, if you can go ahead and write the items that I have up on top. So here we have on the left, we have ETH is thermal energy, EPH is phase energy, and ECH is chemical energy. We're not going to do chemical energy until the next unit. Why don't you go ahead, pause now, copy down the items that are in red above, and then hit play when you're done. Okay, so hopefully you have those copied. Now, as I said before, this is what each of the E's stand for. Now, we always use subscripts in chemistry and in science to indicate, like, for instance, here, ECH. It's energy. What type of energy? Chemical energy. Okay, so you'll see that a lot in science, especially in chemistry. Now, over here in the center, I have ETH, and for ETH, I just put an indication that when we deal with room temperature is around 20 degrees, we're going to go ahead and use 2 bars for ETH if it's at room temp. And then EPH is for phase energy, and the phase energy deals with whether we have a solid, a liquid, or a gas. If we have a solid, we're going to go ahead and draw 1 bar, a liquid 2 bars, and a gas 3 bars. And then lastly, Q stands for quantity of heat, which we'll get to in a few minutes. So let's go ahead and get started. Now, this question here says we have a cup of hot coffee and it cools as it sits on the table. Now, a big key here is that it sits on the table if it sits on the table, think about that. It's going to eventually come to room temperature. Now, we said that room temperature is 2 bars. So we know that because it sits on the table and it cools, it's going to eventually come to room temperature. So we would go ahead and go to the ETH and we would just draw up 2 bars for our ETH. Okay, this is kind of messy, but you get the idea here. Now, it says that it's a cup of hot coffee. A cup of hot coffee, well, if 2 bars is going to be room temp, then the hot could be either 3 or 4 bars. I like to think of hot coffee as being like really hot, like steaming hot, almost boiling. So I'm going to go ahead and I'm going to use 4 bars for my initial thermal energy. So that thermal energy, it's not quite 4, but let's just say that's 4. The thermal energy, of course, is basically all about what the temperature is like. So we're starting out at a high temperature, and then it's ending at a lower temperature, which is room temp. Now, the next thing we're going to do is that it says that it's coffee. So coffee, we know what state of matter it is, and state of matter for coffee is a liquid. So we're going to go ahead and up here it says that for a liquid, we're going to use 2 bars for EPH for the phase. So we start out as a liquid, we're going to go ahead and fill that in for 2 bars. And since it's still a liquid at the end, it's not like we froze it or we boiled it, then we go ahead and we fill in 2 bars for the liquid at the end. Now, my drawings really stink, but you get the idea that we basically want to have 2 bars for ETH, 2 bars for in the final, 2 bars for the EPH in the final, 4 bars for the ETH in the initial, and 2 bars in the EPH in the initial. Now, the last thing that we need to do is we need to indicate whether we are putting energy into the system or whether we have energy coming out of the system. Well, in this case, we start out with 6 bars, we start out with 6 bars of energy here on the left, and we end with 4 bars of energy here on the right. So that means that we have decreased or lost 2 bars of energy. So what we're going to go ahead and do is we're going to indicate that by drawing 2 bars as leaving the system. So we just kind of have an arrow to show that these 2 bars are leaving the system. And then those 2 bars, we're going to go ahead and write Q because that is the quantity of heat. So all we have here is we have an arrow with 2 bars sticking out of the coffee to show that 2 bars of energy have been lost. Last thing I want to mention, because I don't remember if I did already, is to make sure that I mention that ECH, we're not going to be dealing with ECH yet. ECH, we're going to go ahead and leave that out up until our next unit. Now, this next one, let's go ahead and do together. For this next one, we have a can of cold soda. So if we have a can of cold soda, then what's that going to be like? I'm going to go ahead and start with the EPH and the EPH for initial and final. So if we have cold soda and it warms its left on the counter, then what state of matter is that? Well, soda is going to be a liquid. So if it's a liquid, we said on the earlier page, the last page, that a liquid, we're going to go ahead and we're going to fill in 2 bars. It's still a liquid at the end, and so we're going to go ahead and we're going to fill it in 2 bars. Now, of course, this is soda. I forgot to write that. And then for the ETH, well, it says that it's cold soda. Well, room temp is 2 bars, so if it's cold soda, maybe we're just going to go ahead and make it 1 bar. So we have 1 bar, okay? And it warms as it's left on the counter. So if it warms as it's left on the counter, well, what does it warm up to? If it's left on the counter, it warms up to room temp. And room temp, we said earlier, is going to be 2 bars. So we go ahead and we fill in 2 bars worth. Now, looking at that, we have 3 bars over here on the left. We have 4 bars over here on the right. That means that we have added 1 bar. So when we're going to go ahead and draw that, we're going to just draw 1 bar. I'm going to put an arrow going into the soda. And we could just write Q in there to show that it's a quantity of energy that's going into the soda. Now, our next one. Go ahead and try this one on your own. Remember that it says that we have a tray of water at 20, so that's room temp. It's placed in the freezer and turns to ice cubes. At ice cubes, it's -8. Now, I just want you to keep in mind that if we want to talk about something being colder than room temp, we might use only 1 for the thermal. But if it's really cold, for instance, -8, maybe we use a half of a bar or even a quarter of a bar or 3/4 of a bar. So go ahead and try this one on your own. Hit pause, try it, and come back. Okay, so hopefully you've tried this on your own. So let's work this one through. It says that we have a tray of water at 20 degrees. So if it's water, then that means that it is in the liquid phase. So we're going to go ahead and do EPH up to 2 bars like it said on the first page. It says that it's going to turn into ice cubes. If it turns into ice cubes, that means that it's a solid, and therefore it's only 1 bar. So we fill in 1 bar for the EPH. Now, for the ETH, it starts out as room temp. So I'm going to go ahead and I'm going to draw 2 bars to show that it's at room temp. And it ends at -8 degrees Celsius. So if it ends at -8 degrees Celsius, I'm going to choose to do a half a bar. You might have chosen to do a 1 whole bar. That's up to you. The whole point here really is just to show whether energy is being gained by the system or whether energy is being lost by the system. So in this case, I have 4 bars initially. I have 1.5 bars here. And so that means that it has decreased by 2.5 bars. So again, we're going to go ahead and we're going to draw that we have 2. Whoops, I can't really draw that very well, but you get the idea. We want to draw that we have 2.5 bars. So this is kind of hard to do on the iPad. 1, 2, and that's supposed to be a half, but you get the general idea. And then the Q is coming out of the system because we are losing that energy. Now, we are not going to be dealing with ECH. I can't remember if I said that earlier, but ECH we're going to leave out for now.